Hello, testing. Okay, cool. I think it's working. Hi, good morning, or evening, or afternoon, wherever you are. I'm studying system design today because I have a system design interview today, and I don't have a lot of experience with it. Okay, I decided to skip to chapter 10 because the product I'm interviewing today is for a alerting system, and I thought this looked like in the same realm as what I'm interviewing for. So, design a notification system, alerting system sounds useful to know. So I skipped to chapter 10. I think we were originally on chapter 5. 4, 5. Yeah, no, we were on chapter 5. Moving on to chapter 6. Okay, I'll allot the same number of pages for 7, 8, 9, and then 10. Okay. Chapter 10, Notification System. How long is this thing? Dang, it's kind of long. Okay. It's okay, I'll take it step by step. Wait. Oh wait, I skipped too many chapters. Web crawler. Okay. A notification system has already become a very popular feature for many applications in recent years. A notification alerts. Oh, there we go, alerts. Alerts the user with important information like breaking news, product updates, events/offerings. It has become an indispensable part of our daily life. In this chapter, you are asked to design a notification system. A notification is more than just a mobile push notification. 3 types of notification formats are mobile push, SMS message, okay, and email. Shows an example of each of these notifications, okay? It is your responsibility to ask questions to clarify the requirements. Yep, that's the hard part. I often don't know what questions to ask. What type of notification does the system support? Push, SMS, email. Is it a real-time system? Let's say it's a soft real-time system. We want a user to receive notifications as soon as possible. However, if the system is under a high workload, a slight delay is acceptable. What are the supported devices? iOS, Android, laptop. Okay. What triggers notifications? Notifications can be triggered by client applications. They can also be scheduled on server side. Huh, okay. Will users be able to opt out? Okay. How many notifications are sent out each day? 10 million. Push. What's push? Oh, mobile push. 1 million SMS and 5 million emails. Dang, okay. Step 2, propose high-level design and get buy-in. This section shows the high-level design that supports various notification types. iOS push, Android push, SMS. Okay, so iOS and Android are separated too. separate stuff. It is structured as follows: different types of notifications, contact info gathering flow. Oh, that's important. Contact info gathering flow, notification sending / receiving flow. Okay. iOS. Provider, APNs to iOS. We primarily need 3 components to send an iOS push. Provider, a provider builds and sends notification requests to Apple Push Notification Service. To construct a push, I'm assuming the provider is whoever is making the notification, not the cell phone provider. To construct to Apple Push Notification Service. To construct a push notification, the provider provides the following data: device token. Okay. Payload. This is a JSON dictionary that contains a notifications payload. Okay, just the data then. Title game request. Bob wants to play chess. Oh no, what an emergency. Action lock key play. Batch 5. APNs. This is a remote service provided. Excuse me. Provided by Apple to propagate push notifications to iOS devices. Yeah, okay. Huh, this is a really simple architecture graph then, just the provider. Provider, like notifier, to APN, to iOS, okay. Android push notification. Instead of using APNs, because that's an Apple specific thing, right? Apple push notification server, yeah. They probably don't use that. Instead of using APNs, Firebase Cloud Messaging is commonly used to send push notifications to Android devices. Firebase Cloud Messaging. Provider, Firebase Cloud Messaging, Android. Okay. Is this useful to know APNs? So notifications. Apple use APNs. Android use Firebase Cloud Messaging. What's it called again? Apple push notification. Android, it's called Firebase Cloud Messaging. So give me one moment, I need to check on something. Cool. SMS message. For SMS messages, third-party SMS services like Twilio, Nexmo, and many others are commonly used, okay? Is it important to know the exact names? Like if they ask me for specific names, will they ask me for specific names? Twilio, Nexmo, so we have the provider, SMS service, SMS, okay. Email, most of them opt for commercial email services, SendGrid, MailChimp, which offer a better delivery rate and data analytics. Wait, what? So not like Outlook or something like that, or Gmail, SendGrid. I guess they provide email APIs. Email API, okay. What is SendGrid used for? Cloud-based. Forgot what that means. Acts as an email delivery engine, so you can send email without the cost and complexity of maintaining your own email servers. Okay, sure. Just email APIs, I guess. Email APIs. Cool, so it looks like this. Third-party services. We rely really hard on third-party, for this one. Contact info gathering flow. To send notifications, we need to gather mobile device tokens, phone numbers, or email addresses as shown. Okay. Installs our app or signs up for the first time. API servers collect user info and store it in a database. Okay, so the user here, load balancer. API servers store contact info. Oh yes, I was confused on this for a minute. Like which store? Target. No, the servers store the contact info in a database. Okay. And I guess there's multiple servers, it's distributed, so load balancer. Okay, 10-8 shows simplified database tables to store contact info. Email addresses and phone numbers are stored. Yes, that's important. Device tokens are stored. Device tokens are for SMS, right? Is that what it's used for? Device token. Unique identifier used for sending push notifications. Huh. APN device token. APN device token. Register your app with receive a globally unique device token, which is effectively the address of your app. Oh, okay. So it represents the app. It's kind of like a port, on a computer. Is this important to know? APN? You need device token. Okay, makes sense. Only APNs can decode and read the contents of a device token. Okay. Each app instance. Huh. It's each app instance. Okay, unique for each instance. Very cool. Okay, so in the user table, we have user ID, email, country code. Is that important? Country code? Phone number. Yes, that's important. Created at. Okay. Is created at important? I guess it's important for logging, huh? Country code? Huh, okay. device, and then we have a device table. It's an ID, a device token, user ID, last logged in at, okay. Is this important? How do we know to log these stuff? We will first represent the initial design, then propose some optimizations, high level. Okay, service 123, notification system. Okay, and it calls these. Okay. It calls all this third-party services which alerts all the devices. Service 1 to N. A service can be a microservice, a cron job, or a distributed system that triggers notification sending events. Okay. Notification system is the centerpiece of sending/receiving notifications. Starting with something simple, only one notification server is used. It provides APIs for services 1 through N, builds notification payloads for third-party services. Third-party services, we already know this. Good extensibility means a flexible system that can easily plugging or unplugging of a third-party service. Unavailable in new markets or in the future. For example, FCM is unavailable in China. Okay, JPush, PushY, etc. are used there. Okay. 3 problems are identified in this design. Single point of failure, SPOF. Single notification server means SPOF. Single notification server. You mean this thing? Notification system? Hard to scale. The notification system handles everything related to push notifications in one server. Yeah, okay. It is challenging to scale databases, caches, and different notification processing components independently. Performance bottleneck. Constructing HTML pages and waiting for responses from third-party services could take time. I see. Handling everything in one system can result in a system overload, especially during peak hours. Okay, yeah. There's only one server, single point of failure, hard to scale. But what about databases, caches? Different notification processing components independently. Performance bottleneck. Okay, this is the improved design. Move the database and cache out of the notification server. Okay. Add more notification servers instead of automatic horizontal scaling. Introduce message queues to decouple the system components. This is small. Okay. Service 1 through N calls the notification server, which horizontally scales. There's multiple servers. There's multiple caches for the DBs. Okay. I assume the DBs are for like... Wait, what are the DBs for? For retrieving the user information, right? Okay. Cache. Okay, you cache your DBs. Message queues. Okay, so instead of firing off all the APIs and waiting on its own here, we queue them up in a cloud queue and then have asynchronous services. I see. Process. I see. Process all these. Yeah, okay. So this server doesn't have to run all the APIs and wait for them to finish. And these handle all the retries too. Okay, very nice. Okay, notification servers, APIs, carry out basic validations to verify emails, phone numbers, etc. Okay, query the database or cache to fetch data needed to render a notification. Yeah, parallel processing. So all of these can work at the same time. Nice. Cache, user info, device info, notification templates, DB, stores info about user notification settings, message queues, remove dependencies between components. Message queues serve as buffers when high volumes of notifications are sent out. Each notification type is assigned with a distinct message queue, so an outage in one third-party service will not affect other notification types. Yeah, makes sense. Alright. Workers are a list of servers that pull notification events from message queues and send them to the corresponding third-party services. Okay, so this is how everything works together. A service calls API is provided by notification servers to send notifications. Fetch user info. Event is sent to the corresponding queue for processing. Workers pull notification events from message queues. They send notifications to third-party services. Okay. We will explore the following deep dive. Reliability. I forgot what reliability means. Preventing data loss. Will recipients receive a notification exactly once? System should work correctly when under faults/errors. Okay. One of the most important requirements in a notification system is that it cannot lose data. Notifications can usually be delayed or reordered but never lost. To satisfy this, the notification system persists notification data in a database, in a database, and implements a retry mechanism. The notification log database is included for data persistence, as shown in figure 10-11. I don't get it. What is this used for? Persist notification. Does it just log everything it notifies in a database and implements a retry mechanism? Okay. Wait, what is this used for exactly? How to prevent data loss. So this is purely logging. A retry mechanism. Is it like here? Does it read here? Okay, I assume this is just for logging and retrying. It's implemented like here or something. Although notification is delivered exactly once most of the time, the distributed nature could result in duplicate notifications. Wait, how? How could that happen though? Let's see. Service 1, 2. Could service 1 send 2 of these? No. Service 1 and 2 send the same notification. Is that what it means? To reduce the duplication occurrence, although notification is delivered exactly once most of the time, could result in duplicate notifications. When a notification event first arrives, okay, we check if it is seen before by checking the event ID. If it is seen before, it is discarded. Otherwise, we send out the notification. Yeah. Reference material 5. Material 5, where are you? Actually, so confused on this. You cannot have exactly once delivery. You cannot have web browser and server distributed, server and database distributed. At most once, at least once. You can't deliver anything. Too general, not experience. In the letter I mail you, I ask you to call me once you receive it. You never do. Either you really didn't care for my letter or it got lost in the mail. This sounds so passive-aggressive. That's the cost of doing business. I can send the one letter and hope you get it, or I can send 10 letters and assume you'll get at least one of them. Okay. It sounds so... What do you call this? Paranoid? When a message is delivered, it's acknowledged immediately before processing. However, if the receiver crashes before or during its processing, the data is lost forever. At most once, okay. We can acknowledge the messages after they are processed. If the process crashes, okay. We must choose between the lesser of two evils, which is at least once delivery in most cases. Okay, so apparently most distributed systems, client servers are at least once delivery. Okay. Digital access, sound, hi. Oh, hello, hi Digital Act, how you doing? Which language you are teaching? I'm not teaching any language. I am studying system design. It's basically like how do you build applications. In this case, we're learning how to build a notification system in a way that's distributed, aka lots of servers. Yeah, no language. Okay, design deep dive. Oh yes, we were looking at reliability. The distributed nature could result in duplicate notifications. To reduce the duplication, dedupe mechanism. We check if it is seen before by checking the event ID. Okay. Sure, check the event ID. Additional components and considerations. Template, we're using notification settings, event tracking, system monitoring, rate limiting. Okay. Notification template. Body. Okay. Notification templates. CTA. Order now. Save my. Reducing the margin error and setting time. Okay. Notification setting. Okay. So they can set if they want email or SMS. Opt in to receive notification. Okay, rate limiting. To avoid overwhelming users with too many notifications, we can limit the number of notifications a user can receive. This is important because receivers could turn off notifications completely if we send too often. I see. So these notifications are like not that important then? That we can limit how many they can receive? Retry mechanism. The notification will be added to the message queue for retrying. The problem persists and an alert will be sent out to developers. Okay. Security and push notifications. Digital says, can you teach it in practical? Well, the thing is, I barely understand what I'm reading myself. And this thing, that's like an entire company that needs to implement this. Well, I could implement it, but it would take a lot of research, a lot of research and time and coding and money too, maybe. Well, in case you want to know how this works, you have some services that want to push out notifications, right? You set up your, make this bigger. You have a bunch of notification servers that you set up. You can call APIs on them, I guess. And then we have a database full of user information that stores their phone number or, yeah, phone number, device ID, or emails. And then for each of these services, like this one's for, we use third-party services for sending notifications. Like this one's called APN, which is Apple Push Notification for iOS devices. This one's Firebase Cloud Messaging for Android devices. SMS service for text messages. Email service for emails. For each one of these options, we queue up the job in a queue, and then some other servers call these APIs and handle the retrying and make sure that it succeeds. And then the notifications reach the users. Yeah. I think the reason we push all these API calls out to remote servers is because we don't want to overload this one server for needing to handle all the API calls to these. And also we can do them in parallel, handle all the waiting and retrying. Monitor queued notifications. A key metric to monitor is the total number of queued notifications. If the number is large, the notification events are not processed fast enough. Okay, so more workers are needed. Shows an example of queued messages to be processed. Notification metrics such as open rate, click rate, and engagement are important in understanding customer behaviors. Analytics service implements event tracking. Shows an example of events that might be tracked for analytics purposes. Start, pending, error, sent, deliver, click, unsubscribe. 10-14 shows the entire notification system. Okay. So we have the service that sends the notification. We have the notification servers. We have authentication, rate limiting on the server side, I guess. We have a DB for user information with a cache to make fetching common information faster. Okay, I guess it's simplified here. It's just showing the iOS queue right now and the workers. And if there's an error, it puts it back in the queue. Send pending. Okay, we will send our stuff to an analytics service too. The workers will also send it to an analytics service. The user's device will also send it to an analytics service to be like, okay, start, pending, in the queue, error or sent, delivered. I see, okay. And then the workers will also send it to a notification. The workers will also use a notification template and notification logs. Okay. I'm still kind of confused. What's the relation between the notification log and retry an error? Does it, when it queues it back up, does it mark down that it already tried it? And if it reaches a certain number of times tried, then it just gives up? Oh, here. The notification system persists notification data in a database and implements a retry mechanism. Retry mechanisms. Monitor and log the retries and operation. DoorDash developer services. Do not retry indefinitely. How to tell how many times you've already retried. Okay, use a dedicated counter variable within your code that is incremented each time a retry occurs. So you do it all, storing the counter. Monitor and log the retries, log exceptions. Okay, so I guess the retry is locally handled. The log is just pure logging. Okay. Updated design. The notification servers are equipped with 2 more critical authentication and rate limiting. Okay. Why do we need authentication here? Oh, to make sure that the service that's making the notifications are actually... You're teaching better than other YouTubers. That's crazy to say. Thank you. I appreciate. I'm actually studying right now. I'm not teaching. This is a studying stream. But thank you. I appreciate. Okay, authentication rate limiting. We also add a retry mechanism to handle notification failures. Yeah, over here. If the system fails to send notifications, they are put back into the messaging queue, and the workers will retry for a predefined number of times. All right. I'm still trying to think, like... This is a database, right? This is not like just a random string that you store in the cloud. Since they're putting it back into the queue, and there's no telling when you'll retry that job again, I think you'll have to do a database call to see if you've already processed that job again, and then that's how you tell how many times you've retried already, because it's not local. It's not like the retry logic is defined locally, like, okay, 1, 2, 3, 4, 5, check that many times in a for loop. You straight up put it back into another service. Yeah, okay, that's probably it. Notification templates provide a consistent and efficient notification creation process. Monitoring and tracking systems are added for system health checks and future improvements. Okay, wrap up. We dug deep into more components optimization, security. App key app secret pair is used to ensure only verified clients can send. Wait, we didn't go over this. App key app secret pair. Tracking, monitoring. Okay, respect user settings, rate limiting. Okay, we finished the chapter. I don't think we went over this though. App key app secret pair. Did I skip this? Okay, here. Oh, here. For iOS and Android apps, app key and app secret are used to secure push notifications, APIs. Okay, this sounds important to note down. Apple, Android. Let me write this down. App key and app secret. Secure. Okay. Only verified clients are allowed to send push notifications using APIs. Okay. What exactly is app key and app secret? App key, app secret. This identifies the client application that will be requesting a particular server. App secret, this acts as a password for the client application to authenticate itself. This identifies the client application. Okay. This is the ID of the client that's calling the notification system. we will likely have a allow list, I imagine, that says which app keys are allowed to call us. And then app secret is like a password. Okay, so the client application needs to provide the right password when calling the notification server. All right, app key, ID for client. So app key is ID for a client. And we will likely implement a allow list, I guess. And then app secret is the password. Cool. Let's read the wrap up one more time, make sure we didn't miss anything. Tracking and monitoring, respect user settings, rate limiting. Okay, we finished this chapter. Design a newsfeed system. I think I'll spend the rest of my time just silently taking notes on everything here. Yeah. Let's go to the beginning of the chapter again. Actually, I don't know. Is it worth taking notes on all this? It's a lot to take notes on. I feel like I will be taking a lot of notes for very little output. Sir, in which language I do DSA, please tell it. The frick is DSA? You want to implement your Democratic Socialists of America? Data structures and algorithms. Oh. Well, I use Java. Yeah, I use Java, but you can use whatever language you want. Best language for DSA, wow. Oh look, they said Java. People are saying C++, Java, Python. Any of those, I guess. Python. Python seems convenient to use, though I hear it's kind of slow. Okay. Should I just draw everything out? I'm wondering how I should do this, huh? Because I'm doing a virtual system design interview later. How do I draw this out in a system design interview? Virtual system design interview. How do you do it without a whiteboard? Texting has been broken. Oh, they freaking draw it out like this. Are they gonna allow me to go on like a drawing tablet to do this? What would be a good exercise to practice this? Can I try drawing this out for practice? Notification system. Okay, you know what? Let's try this like an actual interview. I'm not going to look at the book or my notes. I'm going to try to, from complete memory, draw out a system design. Yeah. Okay, notification system design. This is going to be... Oh, this is my first time ever doing something like this. Okay. Oh man. How the frick do we do this? Make everything black first. Was my VC face not hidden out this entire time? So let's move chat up. Okay, let us try designing a notification system, like in an actual interview. Okay, so what do I do if they ask me to design a notification system? I'd be like, okay, I don't know. What devices are supported? Okay, iOS, Android, SMS. And email, you say? Okay, does it have to be instantaneous? I guess it doesn't, huh? If it does, then we'll just have to horizontally scale forever, huh? Is that what queues are used for? Queues. Queues are used for eventually getting stuff done, I guess. Message queue. Asynchronous, okay. Queues are good for getting stuff asynchronously done. What would they... So if... okay. So I'll be like, okay. What do we have? iOS. Holy, this handwriting. We have iOS. We have Android. We have freaking pure SMS. We have email. So all of these will use third-party services that handle these type of messaging directly to our users, I guess. Yeah. So we will have, I don't know, client 1, client 2. All call, in the simplest form, all call our notification service. I would be really surprised if you guys can read all this. And then the notification service will call third-party services for all device types. which will reach, the user's iPhones, Android, SMSs, or emails. Oh wait, but then you might be wondering, how the heck are we getting their phone numbers? We spy on them. There might need to be a DB. Yeah, there's a DB. There's a DB that stores all the user's informations. It needs to store the user ID, their phone number, device ID, whatever. And their email stuff. And maybe some logging stuff like date joined or something. Dates are important when logging. Now you might be wondering how the heck do we populate stuff into this service? We might need some separate APIs to have users sign up service. To have users populate their stuff in here. Whatever sign up service our API uses. To make stuff faster, we might need to cache. We might need to set up a cache here to make, popular information gathering faster. Okay, so since it doesn't have to be instantaneous, right? We can do so far it's just this one service that's doing all the work. We could possibly do this in a more distributed way. We could have a load balancer. You know what? Let me shift all this down here. Oh, bam. We have a load balancer. Why is my brush size so big all of a sudden? Load balancer. Okay, that, so our notification service is now a group of servers. Drawing is so tough. Services. Yes, it's now a group of servers. We can process stuff in parallel now. And yeah, these all just send stuff to the third-party services. Wait, hold on, I'm confused. Why do we need a queue? What's the advantage to having a queue in front of all of these? Because we already horizontally scale here. Hold up, I want to read that thing again. Provide APIs for services to send notifications. Carry out basic validations. They also made their databases and caches distributed too. Message queues. They remove dependencies between components. Message queues serve as buffers when high volumes of notifications are sent out. Okay. Each notification type is assigned with a distinct message. Okay, buffers when high volumes of notifications are sent out. Is it like a... Okay, buffers when high... Each notification type is assigned with a distinct message queue, so an outage in one third-party service will not affect other notification types. I see. I see. Okay. So the queues are for... So I guess if we're handling all of this, all of the calls in here, right? All of these API calls are dependent on each other because, say, if the Android call, you know, is failing for some reason, then it holds up. Let's say I'm doing an iPhone, Android, SMS, and email call. If the Android call fails, then it holds up my SMS and email stuff, and I can't process all these in parallel. Yeah. All right. And if, you know, the Android third-party service is just like, I don't know, something happened, like we're getting rate limited, we can buffer everything. Okay. Yeah, it serves as a buffer for third-party services in case something happens, right? Okay. We'll add a queue in front of them then. It's good for third-party services. You have all your queues here. SMS, emails. Because these are third-party APIs, and it will handle the third-party API stuff for some reason offline, or you need to retry logic. We will also probably have another DB that logs, you know, our notifications. So we know how many times we've already retried to. What else do we need? We can make our cache distributed to multiple caches. Yeah, we can shard them based on user ID or something. Database, we can have a master-slave database. We only read from the slave ones, because, you know, how often do users sign up, you know? And analytics. The notification service will will send to the analytics. The queues will probably send to the analytics too. I think it's important to see like how many stuff are there in the queue at any one time. If there's a lot, we could We could horizontally scale our processors, which I'm realizing we're missing. Workers. It's so messy. Retry logic. And these can be horizontally scaled as well. Okay. Okay, let's see how close I was to the solution. System design. Okay, what am I missing here? Let's put my missing stuff in red. Okay, we have, we're missing, we should do auth stuff too. Like allow listing, passwords, rate limiting. Yeah, we don't want to ping users too much. We made our cache distributed, very nice. Database distributed, very nice. Analytics. Oh, our analytics should have some different states, right? We should have like start, pending, sent, delivered, clicked, or unsubbed. That's important to know. Okay, we have our workers, distributed, iOS. We tried. No, we're missing our templates. Templates? Okay, I feel like we got other stuff done though. Where does it say templates here? Events tracking. Wait, where does it say the template stuff? Where does it say all the templates? Oh, here. A large notification sends out millions of notifications per day. Many of these notifications follow a similar format. Templates are introduced to avoid building every notification from scratch. Pre-formatted notification to create your unique notification by customizing parameters, styling, tracking links, etc. Here's an example of a template of push notification. The benefits of using notification templates including maintaining a consistent format, reducing the margin of error, saving time. All right. Templates for building notifications on my side before I send it to the third-party clients. Yeah, okay. I feel like I basically got it then. Okay. Yeah, I feel like I basically got the design then from memory. Let me read through the book one more time. Oh, I'm missing a lot of like specific details. So like Apple uses APN, Android uses FCM. App key, secret key. Oh, I'm missing country code. Do I need this? And they also store like country code. Device token. Last logged in. I guess device token is specific to iPhone or Android. Okay. I feel like I basically got it though, yeah. Okay. Sure, I should be good then if they give me this specific problem. And only this specific problem. God damn. Okay, I think I'm done for today. Alright, thanks everyone for coming. I appreciate. Thanks Digital Hack for coming too. I appreciate. See you guys tomorrow. Bye.